For our Farm in a Box project, we will apply some basic data analysis to compare the results of our different treatments of carrots and spinach. I will be using data from Wellesley's 2013-14 run of the Farm in a Box project for this video. Because of problems that we've had on the Davidson farm in growing the carrots and spinach, we here at Davidson probably have to rely on data generated by Wellesley. Quantitative analysis, and statistics in particular, seem scary to people, but it really is only a formal way to learn from data, using standards and conventions that people have agreed upon. It's obviously more complicated than that, but given people's different level of familiarity with statistical analysis, I'm going to keep things pretty simple and go over things pretty quickly using only one statistical test. There are, of course, many other statistical tests, but I'll leave that for you for your own exploration later on. Okay, today I'm going to use Excel because it's commonly found on lab computers and it's probably on your personal computer right now. When I do use statistics for quantitative analysis, I usually use a specialized piece of software, something called R, which is open source. There are many different packages out there, but really you could do a lot with Excel. And I'll show you how to set up your Excel so that you can calculate some basic statistics, graph the results, and perform one specific statistical test that's most relevant for our work today. First, let's make sure your Excel is set up properly with data analysis turned on. Essentially what happens, if you look here on data, you have no data analysis type function here, because normally when Excel is set up, it's not installed. So the first thing we have to do is turn it on. To do that, you click on File, Options, okay, go down to Add-ins. Down here you'll see Manage Excel Add-ins, Go, and we want Analysis Tool Pack turned on. Go ahead and click both of them, so we also get the Visual Basic material. And then all of a sudden you see this, Data Analysis, that shows up. All right, let's go ahead and open up the data. And as a general rule, the first thing you have to do is take a look at what we've got and see what we need to look at. Okay, so let me go ahead and open up this data sheet. This is data from 2013-14, as I said earlier. And what you have here are, you can see your different boxes with carrots treated organically and using conventional fertilizer, and your spinach, again, using conventional and organic fertilizer. We have different measurements here. We have seeds, we have yield by seeds. Okay, you can see this is the spinach and carrots without tops, all the different measurements that you've made. I'm just going to go ahead and use yield, and I'm just going to go ahead and use this for our exercise. But before we even look at that, let's look at everything else. You can see wet dry weight, take a look at chlorophyll, the Brix test, using Brix refractometer, the leachate, the nitrogen wheat. We have all sorts of things that we can look at. All right, so the first thing to do is, I'll keep it simple for now and just look at yield. And roughly looking at the yield in terms of comparing conventional fertilizer with organic fertilizer, there doesn't seem to be a big difference here between in the carrots. Okay, so it looks like the treatment really didn't matter in terms of carrots. But again, just eyeballing the data, it looks like there is a difference here between spinach grown with conventional fertilizer and that of the organic. Okay, so why don't we go ahead and see if there really is a difference. Note that there is a big variation here. Something went wrong with that box, or something happened to that box. We don't know. But the first thing we have to do is, let's go ahead and grab the data that we want. All right, so let's go ahead and rearrange our data so that we can use it. So here, let's go ahead and copy this, Control C. I made a new blank spreadsheet, and let's just paste it here. Now notice that it did not paste happily, because those are calculations specific to that source, and so we really only want the values. And let's keep the source formatting so that we have the white and gray difference. There we go. Now we got the numbers. All right. Uh, we know that this is carrots, conventional. Actually, I don't remember now. Yes, conventional. The white is conventional. Let's just go ahead and call it conventional. While this is carrots, organic. Here we have the spinach, conventional. And here we have spinach, organic. All right, so first let's test out the fact that our eyeball says that there isn't really that big a difference here. Let's see if that's true. Okay, so the first thing we have to do is we have to put data in a way that makes sense to Excel. Oops, that didn't copy. And the way it does it here Control C, Control V, okay? And this is conventional, while this is organic. Okay, now we have the data the way we want it. Again, let's just add a reminder that this is carrots. Let's go ahead and calculate some of the statistics that we need. The first statistic we need is what is the average? What is the mathematical average of the yields in the different boxes? Okay, so we'll have to calculate the mean. Also, we'll have to also calculate how the standard deviation, or how much each of these values differs from the others. So it's a mean of measuring our variance, and so we'll just put standard deviation there. Okay, the other statistic we need is what is the standard error from the mean? Okay, what that is it's how precise is the true mean of the population. The formula is the standard error of the mean is equal to the standard deviation divided by the square root of the sample size. I'll go ahead and put the formula right here so you can see it as I'm talking. Excel will do this all for us, so we won't have to do any actual mathematical calculations. And then the last thing, just because it makes our graph looks prettier, is let's put the 95% confidence interval. Again, Excel will calculate this for us, and we'll just have to put it in our graphs. All right, let's calculate the mean. This is easy because all we have to do is click, point, and click. So we need it to insert a formula. Again, here, you can click here, or you can find the other ones. And so what I need is I need the average. If you don't know where it is, you can sort through it. But instead of sorting through it, I'm just going to go ahead and I found it right there. Okay, now essentially it says, what is the range for the average? Let's go ahead and choose a range. This is the range right there. And then we're done. Click that, we're done. Okay, so there is our mean. There is the mathematical average of this. What makes Excel nice is that I just copy the formula from this cell, paste it into here, and it will automatically calculate the numbers here. Again, I could have also just hand and drag it, especially if we have different counts. But for now, we can just cut and paste to put it back and forth. All right, now to calculate the standard deviation, same thing. But this time I'm just going to make it quicker. As standard deviation, it's right there. Let's go ahead and click that. And then all we have to do is close the parentheses, and we have our standard deviation. Let's go ahead and copy the formula there. Notice the number is not the same because, again, we assume that this standard deviation will be much larger than this one because of the big difference of this one value. So that seems to make sense. Again, let's also calculate the standard error of the mean. But this, let's just do by hand so you can see how you put formulas in. To put a formula in, you just press equal. Okay, so which is, this is standard error of the mean is equal to the standard deviation divided by, which is the slash sign, divided by the square root, okay, of our sample size, which I'm just going to put by, whoops, I forgot. There's another Excel formula, count, that just counts how many are in the count parentheses. Let's go ahead and click there, okay. And then let's close all the parentheses and we are good. Okay, so that is the standard error of the mean. Again, this would have been easy. It's just this number divided by 2. Because we have 4, the square root of 4 is 2. Regardless, let's just calculate it again to make it smaller. And let's go ahead and do our confidence intervals. This one, it's a little more complicated. So let's confidence interval, okay. Oops, equals confidence. Let's just go ahead. Our alpha, again, 95%, but in statistical terms, this we have to put the 0.05, which is the 5% that's outside. Okay, standard deviation, we just click on that. Okay, and then our size of the sample, again, just to, in case you're, let's use this count function just to, even though we know it's 4, because when you have larger data sets, you'll need to be able to do it. And did I get all parentheses? I did. Okay, so now we have this 95%. This is the range for the confidence interval. Let's go ahead and copy that there and put it there. Now, the reason we have all this is because we want to visually also show the results. Because again, we have numbers, the numbers, are they close? Are they not close? Let's go ahead and graph it.